All right, here are solutions for quiz 6 for Math 213. On this first page, we're dealing with triangle congruence. So you're given two triangles and they're congruent. And so you want to first state the vertices in the correct order and then state the theorem by which they're congruent. So like angle, side angle, that type of thing. So in this one, it looks like I have a side and angle. I have two sides and one angle, and that angle is in between those two sides. So what that gives me is side, angle, side congruence. And the two triangles that are congruent, well, ABC, A is the vertex that's next to the side with length 2 that's not the labeled angle. In other words, it's R. So A corresponds with R here, and B corresponds with W, and C corresponds with I. So I'd say that they're congruent. These two triangles are congruent by sine, angle, side. Same idea here, except now I have two angles and a side, and the side is not between those two angles. So I would say I got the side and the two angles. And by the way, you can also call that angle, angle, side if you want. I don't really care. And for the triangles that they're congruent to, what I want is the angle E, and ABC goes ESH as I go from the angle with one bar here to the empty one to 2 bars. So 1 bar, empty, 2 bars. And then for 3 here, it looks like I got all 3 sides. So my congruence is side, side, side. And A goes to B, goes to C. So I start between the 1 and the 3. In other words, at G here. And then I go across the 3 to N. And then that leaves me with T. Okay, next row here, I got two angles and a side, and this time the side is between the two angles. So I got angle, side, angle. And GHJ apparently is what I'm going to be doing in this problem. Weird. Anyways, G is the angle that's not labeled, so it's A. And H is the one labeled with 2, so it's R. And that leaves E. All right, I got triangle ABC is congruent. It looks like I got two angles here and a side, and the side is not between the two angles. So, I don't know, side, angle, angle. And note, you can also call that angle, angle, side. And then to mark my congruence, I go from the unlabeled angle, so D, to the one with 2 on it, which is S, to T. Okay, here it looks like I have two sides and an angle in between them. So I got side, angle, side, side. And if I want to copy ABC, I start at the marked angle, so H, and then I go across with 2 lines to E, and then to Y. And here I clearly have 3 sides, and I start out between the 1 and the 3, so I guess that's at I. And then I go to between the 2 and the 3, so that's L. And then my last one is H. And here I have 2 angles and 1 side. So I got angle, angle, side, or side, angle, angle. You can write those in either of those 2 ways. Note that the side is not in between the 2 angles. And so DEF, D is the angle marked with 1 line, so I got that A there. E is the unmarked angle, so that's S. And then I get N. And then this last one here, it looks like I have an angle in between 2 sides. So I got side, angle, side. And JKL, well, J is unlabeled and next to the side marked with a 2, so that'd be the H. And K is the other unlabeled one, so that'd be A. And then the last one, L, is the marked angle, so I got a T right there. So there's a whole bunch of congruents, probably more than you needed to do. Probably could have gotten away with 6 of these 9, but what are you going to do? All right, another problem. This one I didn't just copy straight out of Google Images. You're given this picture. And you're first asked how many triangles are there. Well, let's list them and maybe somewhat systematically. I got triangle ABD, so that's this guy. And then I got ABE, that's this guy. And then I got ABC. And those are my 3 triangles that use vertices A and B. But what if I don't use vertex A here? Well, I could say DBC. Or I could say, maybe let's keep these in better order. Let's do DBE up first, and then DBC. So I could do this little guy, or I could do that guy. What if I don't use A or D? Well, I guess I have this EBC. I think what I've managed to do is list all of my triangles. So how many are there? There are 6. And there they are. Which of them are similar? I think to see that they're similar, it helps to label a few more angles. So I got this angle 1 here and this angle 2 here. Maybe I'll call this angle 3. And so note that in this triangle, in any triangle, I have 180 degrees to use. So I used up 1 and 2, and what was left over was 3. If you stare at this triangle over here, BEC, used up 1 and 2, so this right here would be 3. And what that tells me is that this is an equilateral triangle. That might end up coming in helpful later. What else does that tell me? Well, if you look at this big triangle here, I use up 1 and then 2. So what that means is that this right here is the same as this, which is the same as this. So really what I have are 3 similar triangles. Triangle ABD is similar to, well, let's see, I need another triangle that goes from 1 to 2 to 3. So I guess over here, I go 1, 2, 3. It would be triangle BCE. And let's see if I have any other triangles that do that 1, 2, 3 thing. Well, my big triangle does 1, 2, 3. So I got A, C, B. And I think those end up being the only 2 that are similar. I guess you could spend some time proving that there's not anything else similar in here. But I think you will, well, I think you'll say that those are the only 2, or the only 3 that are similar. Determine the length of the line segments below. Show the calculations or briefly justify your answer. AD. So I want to know this length right here. Maybe I'll call it X. Well, what I want to do to figure out X is take advantage of some triangles. If you look at my big triangle here, I know this distance is 7 and this distance is 5. So the distance from A to B and the distance from B to C. So what I have is A to B and B to C. I have this guy and sort of that guy. So I can set that equal to, well, I'd like to know the distance from A to D. Looks like that's this guy. So if I knew the distance from B to D, I think I'd be good. And sure enough, I do know the distance from B to D. So using similarity, maybe I can say, because ABD is similar to ACB, then I have that length AD divided by length BD. That must be the same as length AB divided by length CB. So if I go up to my picture here, AD is what I'm calling X. So X over BD, which is labeled in my picture to be 4, is equal to AB, which it looks like is 7, divided by CB, which is labeled in my picture to be 5. So if I could solve this thing for X, I can multiply both sides by 4 and get that X is 28 over 5. Okay, similar logic. Let's see if we can figure out length DE. So now we're talking about this length right here. That one's going to be tricky. Maybe I'll put that one on hold. Let's figure out CE first. Let's figure out, maybe I should switch colors, this guy. And the reason I know to do that is if I could figure out this guy, maybe I could take advantage of this entire length to figure out Y, because I don't have a whole lot of information about Y right here, this triangle. It's not similar to any of my known triangles. So let's try to figure out Z first. So I want to know CE. That's this guy. Let's look at this triangle and figure out what else we know in this triangle. Well, it looks like we know BC. So I got this guy. So what I want to do is look for either of my other triangles where I have those 2 pieces of information, the first 2 and the second 2. Well, I think I have that here, right? I got AB is given to me, and BD is given to me. So I can set those equal to each other. Maybe I should have drawn those in different orders. I got the BD to correspond with the CE, and I got the AB to correspond with the BC. So I'm trying to figure out CE here. And so I could say that length CE, maybe I'll call that, let's do it like I did before, CE divided by BC has got to be equal to BD divided by AB. So let's see, CE is what I'm calling Z. BC is labeled as 5. BD is labeled as 4. And AB is labeled as 7. So when I do this multiplication to solve for what Z is equal to, I get that Z is equal to 20 over 7. Let's see, so the two other pieces that I need are DE and BE. I'm going to do BE, well, let's save that. Let's do DE, which is Y right here. And I think that's the hardest one on this test. So to figure that out, note that if I could figure out AC, I'd be good. And I think I can figure out AC. I want to know AC. I have, for example, CB. And so I can use what I also have over here, BC and CE, to solve for AC. So I'm trying to solve for AC. Maybe I could say that, I don't know where, over here I guess. AC divided by CB has got to be equal to BC divided by CE. So AC is what I'm trying to figure out. AC is x plus y plus z divided by CB, which in the picture looks to be 5. And that's equal to BC, which in the picture is 5. Divided by CE, which in the picture is Z, which I solved for was 27ths. Maybe use a calculator so you don't get this fractions inside fractions. But if you do, you can still deal with it. You got x plus y plus z. If you multiply both sides by 5, I get 25 over this fraction, which if you multiply by the reciprocal, maybe I'll write it all out here. I got 25 over 1 times 7 over 20. Which is equal, so I got x plus y plus z, and you're probably doing all this with the calculator, and that's fine. I'm going to reduce this, call this 5/4, and 5 times 7 is 35 over 4. But that's not my answer. That's x plus y plus z, and so I already figured out that x was 28/5, and I want to figure out what y is, and z I know is 27ths. And that's got to be equal to 35/4. I think I'm going to finally break down and use a calculator here. Pull this up. So I could solve for y by taking this 35/4 and subtracting 27ths. And then subtracting 28/5. And getting this 0.2929, I guess. Maybe I'll call it 0.293. So that'll be this answer here, 0.293. And you might be a little bit overwhelmed at this point, and I can understand it for sure. The good news is that EB will be really easy to figure out. And the way I can figure out EB is note that this is an isosceles triangle. So I don't even need to use triangle similarity. I could and figure out that answer, but I think it'll be easier to just say, wait, if this is isosceles and this length is the same as this length, so I'll say this equals 4 because this triangle DBE is isosceles. And I guess I'll call that good, end this here.